Welcome to a brand new Transit Unplugged TV special filmed here in Salt Lake City, Utah at the Stadler Train facilities. We're with Martin Ritter, who is the CEO. Martin, what are we going to do?
Paul, we're going to see how to build a train.
How to build a train. I love this. Let's go.
Well, welcome at Stadler here in Salt Lake. Really glad that you guys are here and taking a sneak peek on our wonderful facility here.
Martin, tell us about Stadler Trains.
Well, Stadler is a Swiss headquartered manufacturer of trains and maintainers and signaling systems as well. In the US, our headquarters is here in Salt Lake City. We have globally about just shy of 17,000 employees. Here in Salt Lake City, we're just around 700 heads at the moment, and we keep growing. We have this facility that we're standing at right now. We have that since open since 2019, so only 6 years. And so far we were growing significantly, and not only with people, but also in the scope we did. Like we started with pre-assembly and panel assembly and final assembly, then we added commissioning, we added a paint shop later on. We just opened recently a aluminum welding shop, so we're welding the car shells here in the meantime, and sandblast them and paint them.
That's awesome, man. So tell me about the kind of trains you build here and what makes them special.
Absolutely. Well, currently we're building commuter trains for the Bay Area, for Caltrain. Those are bi-level cars. We see those behind us. And then we're also building the MARTA subway cars for Atlanta.
That's great.
We do have projects in the next couple of weeks actually starting, and we'll see later on in the welding shop that we have them welded already. We're building the Metra commuter trains for Chicago, right? And then we're building Caltrain's hydrogen trains for the state of California. We're building together with a cooperation with the Utah State University. We're building a battery train as well. Talk a little bit about that too. And we're building some more trains for Textron Trinity Metro in Fort Worth as well. So those are all coming online the next 6 months in terms of final assembly. And then we're going to start with the light rail vehicle contract with UTA. That's supposedly starting Q4 next year with assembly.
It's awesome. I love this assembly line you've got going here, the old Henry Ford style assembly line. What makes these Stadler trains special? You've got like a special sauce.
Yeah, well, on one hand, all those trains are made out of aluminum.
Okay.
So they're built very efficiently. They're lightweight, technically. That makes it very efficient in terms of energy consumption too.
Yes.
Besides being very safe with the crash energy management system we have. And talking about the propulsion system and efficiency, well, once you want to go, our baseline product is based on an electrical multiple unit with catenary, running on the catenary.
Okay.
That's our baseline design. And then because in the US we don't have that much catenary yet, we did the first train for Trinity Metro was a diesel electric train, which had diesel engines in the middle in a power pack that generated electricity, and they powered a train. Now, in the meantime, we went to zero low emission vehicles as well. And that was actually the nice part is from the beginning, that power pack allowed us to be equipped with the diesel, or which we do for California with fuel cell technology for the hydrogen, or for Chicago, we filled it with batteries. And so Chicago is going to receive a battery electric train. Most of the train will remain the same as a diesel or an EMU or an hydrogen train, but the propulsion generation on the car is a different technology.
All right, we're inside one of these trains. Who's this one for?
That's still for California, for the Bay Area, the bi-level
Is this
cars.
a two-level one here?
Yep.
All right.
So we're on the lower level right now because there's no stairs yet. The steps are not installed for upstairs.
Okay.
And this is the process of being, basically we call that basic structure. We're putting insulation on and we're putting the frames on for the cables.
And what would be something that would surprise an average person about making a train?
Well, two things about our trains. First of all, they're made out of aluminum.
Okay.
I think that most people see that steel trains heavy, they're light and aluminum made. The second thing is really when we think about building trains, it's kind of the steam locomotive theme that we have.
Right.
But this is actually more like building a plane.
Oh.
We have on one of those Caltrain cars, trains, we have more than 35 miles of cable installed.
Wow.
So they're really becoming an electronic car more than actually a mechanical car.
That's amazing.
It is. It's a lot of electrical. a lot of work for electricians too. Yeah.
Oh yeah, yeah.
And that's surprising sometimes as well, because to maintain those trains, you're not really relying on the same skills as maybe 30 years ago we relied on trains, right? We have passenger information systems, we have diagnostic systems, we have train control systems. That's all electronic, a lot of software. So you need different skills now to maintain a train that we used to use with more mechanical side. We're more on the software and electronic side.
That's interesting.
Yeah, so here we're in the training room of our youth apprenticeship program. The first year or the first quarter of the first year, they're spending here in this room and get the basic education, basic skills on machines, on material. It's a 3-year program that we designed together with the state of Utah. We have 3 other companies that they're doing exactly the same as well, and we're trying to grow into other trades as well. Obviously, we're going to add most likely by next summer a job for the welders as well. So
okay,
we do apprentices for welding, and those kids are all in the high school still, so they're spending A or B schedule here on site, and the other part they're at schools. It's roughly 50% school, 50% at Stadler for the first year, and then when they go to college, it's about 80% at Stadler.
Oh yeah, love it. Look at these. So Martin, we're in your truck shop?
Yeah.
These are the trucks, right?
Yes.
Tell us all about this.
That's where trucks are built here at Stadler. Well, the truck is actually a very, very important part of the train. It's important because of the ride comfort. It's important because of safety, to avoid derailing, right? And it's an important piece when it comes to long-term costs, life cycle costs. I mean, the way how trucks are constructed, designed, and built has a big impact on the railroad, on the train.
This is what's underneath the train car that I'm riding.
Yes, so that's where we have 2 wheel sets per truck, and then this is not, I mean, if it was a motorized trucks, you would have 2 motors on it, 2 gearboxes, and then obviously you have the suspension system on it.
Yeah, it looks like a big shock absorber there.
Yep, our trains are all living with air suspension systems as well, which is really great for the ride comfort.
And this is what hits the track. What's this made of?
Those are the wheels. That's steel.
Okay.
Yeah, steel on steel.
Big steel, baby.
Yep.
Yeah.
I mean, the entire truck is made out of steel. I mean, the frames are out of steel. The bolsters are casted actually in this case. Depends a little bit on the design. And then there's power trucks and non-power trucks.
Okay.
The power trucks will have in our case, right? Because the multiple units have a distributed power system. Whereas if you're most likely familiar with push-pull, like a locomotive and cars, those cars, they cannot move on them.
So this is the old style train that had a locomotive up front that pull 6 cars. Yeah. That's not what you build, right?
No, we build multiple units, whereas we have the power distributed among the train. Like Caltrain, as I said, for example, it's a 7-car train set. And out of those 7 cars, we have 8 trucks are motorized.
So that's where the power's in.
Yes.
That's awesome.
And the other 7-car makes 14 trucks, 8 are motorized, 6 are non-motorized.
Interesting.
Or just running.
Yeah. And what's the cool thing about that? I mean, why did you choose this instead of the old style?
Well, there's performance-wise, you can acceleration rates can be higher. You can lower your axle rate because the locomotives are very heavy, and with that, they're heavy on the infrastructure because you have higher axle loads. We have lower axle loads with our trains. There's some side effects as well. For example, our engineers, like the engineers running with our trains, they love our trains over a locomotive because a locomotive is not built to hold people. A locomotive is built to pull or push trains, cars, right?
Right.
So the ride comfort on a locomotive is not great. But here, the engineer of a Stadler train is the first passenger. So they get the same ride comfort as everyone else on the train. That's why they love, besides other things, they love our trains.
Is there a conductor, like on your, like if this is out running, is there some guy or gal in charge that's driving the train?
Yeah.
Where do they stand or sit?
That's at the end, on both ends. I mean,
both
our
ends,
cars go in bi-directional.
Oh, that's
go
good.
both directions, right?
Yeah.
And now we can go through one of those driver desks real quick as well together.
That's kind of good too.
Yeah.
You don't have to turn the train around.
No.
Like the old roundhouse in Baltimore at the B&O Railroad, there's a roundhouse where the train used to have to go around and turn around. Just go to the end and then go the other direction.
No turning tables.
That's great.
Well, those are the wheel sets, right?
Okay.
Going underneath the trucks.
Right.
And you see this is a version with a gearbox on it.
Okay,
And then the first one is a version for a non-powered truck, no gearbox.
gotcha.
Right.
But these ones would be when they have power in them.
Yes, so there's going to be a motor attached to the gearbox, and
Okay.
then, yeah, that's how.
Very cool.
We always have two, like a redundant system per truck, right?
Oh yeah.
So you never have one gearbox and one engine or motor only per truck. You only have a redundant system. Well, Paul, you can imagine it not only takes a lot of people and brains to build a train, it also takes a lot of material.
This looks like at the end of Raiders of the Lost Ark when they pushed that thing all the way to the end of the warehouse.
Yeah, sometimes it's really an endless story.
Yeah.
You can imagine if you don't track those components accurately, you're going to lose them. You're going to be looking always for lost parts. So obviously, as being responsible for the P&L, I would wish our inventory was lower, but it also has to do with resiliency of the business. If we only plan on just-in-time production, then if a ship has delay, if
Yeah.
COVID situation,
Right, you're
if a
subject to the
tariff,
vagaries
I mean,
of
it's
the-
just like
yeah.
so many things happened the last 5 years
Yeah.
that would have led us to a production stop. That of course we like to have a little bit of inventory so we're more flexible and resilient.
And you track all this with RFID kind of stuff or whatever you.
Well, it depends a little bit. So we have on some projects we do have RFID tags already, so we know exactly what part is. It's also relevant for the customer afterwards because they have an RFID tag solution on the train. They can identify the part and they can order new parts, etc. So, and the other ones they're with article numbers and identified by the suppliers.
Okay, gotcha.
Like the old style with a QR code, and we track them in our ERP system.
Well, this looks like a massive warehouse, and you told me you have two of them?
Yeah, unfortunately, yeah, yes. Well, here we're in our displacement hall, which is technically a logistic hall for bigger components.
Okay.
So behind us, you see the trucks. They're staged here. They're ready. Once the car shells are done, then we're going to marry the trucks with the car shell. That's a process that takes a little bit of space, obviously, because it's such a big
You're
component.
kind of putting them up underneath the car.
No, we're taking the trucks.
Okay.
We place the truck on the rail.
Okay.
And then we take the car shell and put it on top of the trucks and lower it down on the
Welded
trucks.
on and all that stuff.
No welding.
No welding.
That's bolted. Yeah, yeah.
That's good.
And we have those center pieces. It's basically a pin. So it's a pin system. So most of it is actually not the bolting is security, but here that's the pin that the car shell is sitting on.
Well, it makes sense because sometimes you have to take it off, so you can't really weld
And you need. I mean, it needs to be able to also lift a little bit.
Oh yeah, like bridges do. They have things in bridges for that. Yeah, cool. What's in the? You got a welding shop in there?
Yes, we're gonna. Let's go in
let's do
and
that.
see the
then
real
I'll-
manufacturing.
There you go. Yeah.
Well, here we're standing in our welding shop. That's
Okay.
the newest, the latest edition.
Oh, nice.
We started just a few months ago with welding the first car shell, and one of those first car shells is the one behind us that we're doing right now, measuring whether the car shell is within the tolerances. Because when you weld, there's heat and material kind of reshapes, right? So you want to make sure that it's within certain tolerances. Behind us, we do have those jigs, massive jigs, whereas we put the floor, the walls, and the ceiling in, we tied it together, and then we weld it.
That's good. Now you here at this factory in Utah, you have to do Buy America, right? You have to have at least 70% of your train built here. Is that the idea?
Yes. So in terms of Buy America compliancy, since we're now welding ourselves as well, we're somewhere between 85 and 90+% of Buy America compliancy, which means that over 80% of the material, the components going into our final product are Buy America compliant, or substantially built in the US, or have substantial amount of material from the US. And they're coming all over from the nation. We have many suppliers on the East Coast.
Okay.
We have many suppliers, or a few suppliers on the West Coast, and we also have suppliers here in Salt Lake.
That's great. So with so much happening right here in Salt Lake City, I imagine you're having a pretty big impact on the economy, huh?
Well, yes, actually, of course, we do have 700 direct employees here. We did build and invest way over $150 million in this facility, building it with local contractors and builders. and like running, maintaining everything. That's all local jobs that we're creating. But we also have almost 300 suppliers from the valley here.
Wow.
So we have a big ecosystem of suppliers or service providers here in Salt Lake City. Well, after the welding, we're pushing the car right over here and we're doing the sandblasting. And sandblasting is important for two reasons. On one hand, we're cleaning the surface because after the next step is going to be paint. So here we're actually on the third floor of the facility, and we're producing panels and harnesses here and connectors.
Oh yeah.
If you remember, I told you over 35 miles per
This
Caltrain.
is some of them, huh?
That's some of those 35 miles on a train.
You do that here?
We do everything here. So in the back there, we have those tables where we cut the wires to the exact length.
Okay.
And then we're building the harnesses. And here we have the team building all the connectors to the harnesses. So you see, like you pointed out, this is a connector being connected here. We have smaller connectors there. And then on this side on the facility, we're actually wiring our cabinets, electrical cabinets.
Oh,
so
yeah.
We can look at one here. Yeah, this is where quite some work goes in to basically, we got tons of wires going into the cabinets, and there's always one employee per working on one cabinet. We don't hand it over for quality purposes. So you start and finish your cabin, electrical cabin, and they're up to almost 4 weeks on the largest. This is not the largest. On the largest cabinet, it can actually take up to 4 weeks to build one.
That's amazing. So this is on the train.
This eventually goes on a train and has different functionalities.
It's like it looks like a telephone junction box almost, you know, with all the communication wires. Yeah. Wow.
Well, and again, like communication is becoming a big deal on our trains, right? That not only, I mean, if you look at the new MARTA cars with the passenger information system they have, like before we had maybe, if we had one screen or two screens at the entrance, now we're talking 10, 20, 25 screens per car for information, for advertisement, for entertainment. Yeah, software is obviously an important component in the meantime of the trains. Here in our software lab, we're testing the software before it goes on our train, so we can really improve the quality of the software and functionalities.
Good.
Before we do
it's a big part of it.
Yeah. Well, here in the commissioning facility, we're basically testing the whole train several times.
It's been built.
It's been built, it's put together with the trucks, right? And now we're testing the train. We're testing all the electrical connections. We're really, I mean, the whole train statically, but then also dynamically will be tested. We'll go and look at the test track as well.
Yeah.
Whereas we do dynamically test the trains before we send them to the customer.
I remember when I was at MTA in Baltimore, when we would have trains and buses built, we sent people to like inspect in the factory. Do you guys have that here?
Yes, plenty of. Yeah. Depends a little bit on the customer, on the project. We can have up to 3 or 4 resident inspectors, and they're basically here through the entire build and testing of a train, and they're kind of watching
over your shoulder,
over our shoulders, and see what and just understanding the quality and that process is right. And then there's also a numerous of process to accept the train, right? We have a release for shipment document, whereas over a week, like this is happening right now here on this train. The customer was here this morning and did a final look on the train and said, yes, this train is ready to be shipped. And then once it arrives in Atlanta, we will then also go through and check the train for potential damages from the shipment.
Okay.
But then also we might have had some open points from our factory acceptance that we then fix, fix in between, and then there is a conditional acceptance, finance acceptance, there's burning phase where we have to run the train for several hundreds or thousands of miles without major defects in between, etc. I mean, there's a whole different.
Yeah. So 8 to 12 months to build it, and then how long does that thing take?
That's very individual.
Several months?
It's very individual. It can take a long time. Depends a little bit on the process that the customer has set.
Yeah.
It's very individual.
Now, once you do all this here, do you run it on a track to kind of test it?
Yes. So
can we look at that?
Yeah, absolutely. Let's go look at the test track. Well, here we're in the commissioning hall, and once the train is commissioned statically and built, then it's going to actually leave the facility here to be tested on our test track.
How long is this thing?
It's electrified just over half a mile.
Okay.
And it's almost a mile non-electrified. So the diesel multiple units we can test a little longer. We have DC third rail and we have AC overhead catenary. And then we're also like modifying our AC overhead catenary to a DC overhead catenary, so we can actually test everything. Everything that's available on the market.
All right, so we're at the end of the process. You've done the commissioning, everything is cool. How do you get it to the customer? I mean, you know, you got to get this one to Atlanta, you got to get that one to California. What do you do?
Well, it depends on the product and the project. The Caltrain cars, they're going to be pulled by locomotive over the freight railroad.
Union Pacific tracks, or?
Yes, it's a UP tracks to the, and sometimes BNSF, obviously.
Yeah.
Texas, we did that too.
Okay.
The flirt, we pulled the flirts to Texas. We coupled several together and pulled them down there. For Atlanta, it's a little different. Those cars, it's more effective and efficient to ship them over road. So we truck them.
They're subway, so you don't have subway tracks all the way there, right? Yeah.
So, yeah, the MARTA cars, the subways, we have to truck them.
Right, because you don't have subway tracks all the way to Atlanta.
Well, on one hand, and it's faster, it's more effective.
Okay.
And then, but we did invent a ram.
Okay.
So we kind of load them on a flatbed truck very efficiently, and then also offload them in Atlanta over that.
That's cool.
Ram.
And then when it gets there, then you go through that process you mentioned where then you do the final commissioning, right?
Yes.
Thanks for joining us on this Transit Unplugged TV special, How to Build a Train, at the Stadler Rail Factory in Salt Lake City, Utah.